Hi everyone, my name is Katie Deutsch and I am a junior at Frisco High School. This year I was a part of both the track and cross country team along with NHS and FCA. This year I chose to study forensic science. I chose forensic science because I've always been interested in criminal law and the court system. And I've also been strong in math and science, so I figured it'd be a good combination of both. My goal for ISM this year was to expand my knowledge and gain a deeper understanding of the field of forensic science, and also to develop skills and habits that will benefit me in the future. I took ISM because I wanted to, when I go into college, I wanted to be sure that I know what I'm doing and not have to change my major. I don't want to spend time and money and end up being unhappy with what I'm doing. So my quote for this year is, "Unless you try and do something beyond what you've already mastered, you will never grow," by Ronald E. Osborne. I picked this quote because I think we all know that it's easy to take the easy way out or take the shortcut, but I really want to take advantage of this opportunity in ISM, and so I chose this quote because I think it's motivating, and you're never gonna reach your full potential if you don't do your best and try something new every time. So what is forensic science? Forensic science is the processing of physical evidence from a crime scene for a legal investigation. It's a really important part of the criminal justice process because it gives the investigators details on what happened. It reveals things that can't be seen right at first and can't be gathered through witnesses and interviews. You've probably seen it on TV shows such as CSI, Criminal Minds, and Bones. Forensic scientists process crime scenes and then process evidence that is used to assist investigations. Some of the things that forensic scientists do include fingerprinting, ballistics, which is analyzing bullets or guns, gunshot residue, and then blood and DNA analysis. Everything that is gathered and all the information that they put together is used in court. So this year for my research, the first thing I researched about was the origins of forensic science. It was all started by a medical legal pathologist in France in the 1800s. His name was Edmund Locard, and he wanted to revolutionize criminal investigation. He believed that he had a very high belief in physical evidence and that every touch left a trace. And so he wanted to open a crime lab and really increase the amount of evidence analysis that happened in criminal investigations. But most people thought he was crazy. He didn't have very much support or funding at all. So he started out assisting on high-profile cases with the police, and they realized that what he was doing had some value and it could turn out to be something great. So eventually he got enough support and funding to open the first crime lab in 1912. It was also in France. Not only did he open the first crime lab, he created the technology that is the basis for many of the procedures that are done today. So fingerprinting, facial recognition, and reconstruction are all, the core processes of them are all based on things that he created. With the new crime labs, they were able to solve more crimes that had little evidence, and he became known as the father of modern-day criminalistics. The next thing I researched was Katie's Law. Katie's Law was created by the parents of Katie Sepich, who was a New Mexico State University grad student, and she was 22 years old when she was walking home from a party, and she was trying to get into her house, and some guy attacked her. He raped her and strangled her, and when he disposed of her body, he set her on fire. So they were able to, when they opened the investigation, they were able to get DNA from her attacker, but they weren't able to match it, and they didn't get a match until almost 3 years later. So her parents were inspired to research the impact and the importance of DNA in criminal investigations, And what they did was they wrote up Katie's Law, which required, or not necessarily required, but allowed for DNA to be collected from anyone who was arrested from violent crime. So that includes kidnapping, homicide, sexual assault, and robbery. This helped. It also provided funding for them to get the materials and machines they needed to do this. This helped solve crimes and match DNA to people who had been arrested, because most people, it's shown that most people arrested for robbery have been arrested multiple times, and so it was able to connect previous arrests with ones that were happening. My last topic for research was the difference between how forensic science is portrayed on television and how it is in reality. Forensic science is seen a lot on TV shows such as CSI, Criminal Minds, and Bones. I also asked the people I interviewed about what they thought the main difference was, and most of them believe that the processes they do stay fairly accurate. It's definitely just a stretch of reality. The biggest difference is that it takes much longer in real life. In the shows, they're able to complete analysis and do things in a short amount of time, but in reality, it takes more like 1 to 2 weeks. Another difference was they spend their time in the lab or on crime scenes. In television, a lot of times you see them investigating and assisting the detectives, which isn't really something that's common. And also another difference was not everything that's seen on TV is able to be held up in court. So something like taking fragments from fingerprints and piecing them together to create one, and then like running that to get a match for fingerprints wouldn't hold up in court, because you can't really assume that they're all from the same person. Next, my interviews. I had 6 interviews this year. My first interview was with Dr. Tracy Dyer, a forensic pathologist at UT Southwestern. I was really, really nervous for this interview because it was my first one, and it was all the way at UT Southwestern, and luckily my mom drove me because I was at UT Southwestern, which was a lot bigger than I thought it was, and so we got there and I was like at the oncology building, and we're like, okay, well, where do we go? So I gave her a call and she was like, oh, well, we're not actually on campus, we're down the road a little bit, like 3 minutes and you'll be there. And I was like, oh, okay, good. So we drove over there, and it was really stressful because we didn't really know where we were going, and thank goodness my mom was there, otherwise I probably wouldn't have made it. But when I got there, she was really nice and understanding. She gave me a tour of the entire UT Southwestern Forensics Division, which was really cool. She took me through all the labs, and I got to go, there's like 3 levels, and I got to go through all of them. And I got to see where they do the ballistics testing. And that was really interesting because they have a shooting range basically, and at the end there's like this little catch where they can, where it like slows the bullets enough, and they can test the guns, things like that. And they also have a water tank which allows them to fire into it, and it slows the projectile enough so they can retrieve the bullets and compare it. At this interview, I really learned how great of an opportunity this was. She told me that she changed her major in college, and she had to go back to school for 4 years to become a pathologist. And she told me to really take advantage of ISM, because if she had an opportunity like this, she said she would have taken it, and maybe she could have avoided changing her major. Also, she said focus on your grades because they'll be with you no matter what career you choose. My second interview was with Michelle Bobel. She's a criminalist at the Plano Police Department. She was a mentor previously, so she really knew how to help me, what information I needed. Here I got a feel of what the atmosphere was like working in a police department, working in forensic science. And it was really interesting. She shared with me all of her stories about like the first case she ever had, and it was super crazy, and she thought she had no idea what she was getting into. They like knew what this guy did, but he was like only telling them bits and pieces of like what he did, or like where, like they didn't have a body or like any evidence. So it was like some sort of like, they just had to find all this evidence and put it all together, and she had no idea what she was about to get herself into. But she thought that was the craziest thing she's ever seen, and it's normally not that intense, I guess. My third interview was with Dr. Lynn Salzberger. She was the Assistant County Medical Examiner at the Collin County Medical Examiner's Office. This is a really good interview. It was supposed to be with someone else from Briscoe High School that's doing like forensic pathology, I think, but they thought she worked at her old office, so it ended up being just me. But she gave me really thorough answers to all my questions, and she showed me around the facility, and she told me about how it wasn't the most glamorous profession at all, and if you're afraid to get a little dirty, you weren't going to be very successful, because you have to be able to put up with that. Next, I had my fourth interview with Special Agent John Skillstad of the Dallas FBI. I got his contact information from Sarah Meeks, and I went and interviewed him, and it was really crazy because the interview was at Hall Office Park, and there's actually an FBI residence agency there, and I had no clue. But when I got there, I had to go through this metal detector, and it was actually really interesting to see there's all this stuff in here I had no idea about. But even though this wasn't really the field I was looking to go into, it was a good interview because he had a lot of experience and so many different things to share with me, and I actually learned a lot about what the FBI does and the different divisions of it, and it was really eye-opening to see how much goes on and we have no idea about it. He also gave me a few contacts within the FBI. I wasn't able to interview with them just because of scheduling, but it was still a really good interview. Fifth, my interview was with Tamika Robinson, a criminalist at the Frisco Police Department. When I got there, her coworker Stephanie was there also, so it was kind of like two interviews in one, which was nice. I got two different opinions on my questions, and they showed me around the crime scene, or the crime lab, and I got to see the van that they take to crime scenes. She gave me a lot of information on what schools were good for forensic science and things like that. And she also gave me a couple links to websites for resources and online courses to look at. My last interview was with Callie, and she works at the Allen Police Department. I got a lot of information on what it's like to work at a police department since it's so male-dominated. And she also advised me against getting a career in criminal justice because once you get a degree in criminal justice, your options are so limited. And if you decide you don't want to do forensic science, there's not much you can do. I learned a lot from all my interviews, and I think that all of them contributed to the way ISM played out for me this year. And I was very thankful that all of them took the time to help me. Oh, shoot. Forgot about that. Okay, my mentor is Callie McClendon. She's a criminalist at the Allen Police Department, like I said. At the start of our mentor visits, we really got started working on my original work right away, which was really cool. She helped me come up with an idea, which I'll talk about later. We realized that fingerprinting was a good route to go because it was accessible and it didn't require too much. It wasn't very complicated in the sense that there's a lot of different equipment. One time when I got there and she was out on a call, and I got to go up to the criminal investigations, and I got to look through a binder about fingerprinting, and I took notes, and this actually worked out really well because it gave me an idea for my final product, which I'll also talk about later. So that worked out really well. I've had a lot of good experiences on my mentor visits. I learned a lot about the processes that go on in forensic science, so then my original work, there's my mentor on the left, and then her coworker Lauren. Okay, so my original work, what I did was I researched the three most common types of fingerprinting. So there was just dusting using black powder, super glue fuming, and then ninhydrin processing. So I researched each one, and then I actually got to perform each one with the help of my mentor. And so first was the dusting for fingerprints. So there's 2 different kinds of black powder, and there's magnetic and then just regular. So what I learned was it's used on mostly like non-porous surfaces, like things that can't be moved from a crime scene, so a table, etc. One thing about like the dusting is you can, if you like press too hard on it, it can damage the fingerprint. And this also really helped me see that fingerprints are such a chance impression. You can't always get enough detail to run a fingerprint from each one. So here are 2 examples. The smaller one, you can tell that there's obviously fingers there, but there wasn't enough oils or to get an actual detail. And then on the larger one, it's from a coffee mug. That's why the hand is so freaky. And that one has really good detail. You can see like the outlines of the fingerprints and all the details. And then also the other type of black powder is magnetic. And on this one, it's hard to see where the fingerprints are. Here you go. But they're like by the blue arrows if, when you look at it. The difference in this was it's just magnetic powder, and so you don't really have to like dust the powder on there. You just kind of like rub it, like just kind of touch it lightly, and it picks up on the oils that are on in the fingerprints. So here you can see both the examples that are getting passed around, and this is the magnetic. So it's harder to see the fingerprints on these, but it actually still worked well. The 2 black marks are from my final product, so I'll talk about that in a minute. Secondly, I had super glue fuming, which is used on, we did it on different bottles, and we also did it on a CD case. So what happens is there's a heat source, and the super glue turns into a gas, and it adheres to the same amino acids that are left behind when you touch something. So that's how you're able to view the fingerprints. And then after that, what we did was we covered it in a chemical, and that allowed us to view it under different light wavelengths. I'm going to really enhance the detail and made it easier to see which fingerprints we're going to be able to put into the system or things like that. So this is, we used a Coke bottle, and so you can see like there's a white residue, and that's what the super glue is. And then after we put like a chemical on it, we were able to view it under these lights. And here you can really see, like right here, there's like the bridge detail, and then up here a little too. And we were able to see like the details in the fingerprints that you can't really see just looking at it. This one's even better because you can really see it, just it's everywhere, like right here, and then especially down here. It was really interesting to see like what's there, but like you can't tell. And then lastly, I had ninhydrin processing. So this is used mainly on paper. When the first time we did this, we used the iron as a heat source, and when we did it, the iron started leaking all over, and I had to start over. But what happens is we took the papers and then we covered them in ninhydrin, and then after they dried, we were able to use the iron to, it reveals like the fingerprints, and it gives them a purplish tint so you can see where they are. So here are, it's really hard to see on the images, but you can tell like there's like one here and one here. It's on the paper that I passed around, and then also on this one. You can really see the different different fingerprints. There's like 1, 2, 3, 4. And that was really cool. It was hard to get fingerprints like good enough to show up on the paper, but we actually got good ones. That also really showed like how much of a chance impression it is to get a fingerprint. There's something called the CSI effect, which in TV shows they always have physical evidence. You know, there's DNA, fingerprints, things like that. But not every time you get a fingerprint are you going to get enough detail to run. And so that really reiterated, like, even if there is a fingerprint there, like, it might not be clear enough, or it might be, they might have, like, slid their finger, something like that. And then on to my final product. For my final product, what I did was I took all the processes that I learned from my original work. And this is really neat because I took everything I learned from my original work about fingerprinting and the differences between the processes, and I applied it to my final product. So what I did was I researched the 3 different kinds of fingerprints, and then I processed like 6 different things and lifted all the fingerprints. We dusted them and then lifted all the fingerprints. That way I would classify them. And that's where the research came in. What I did is I took what I learned and I picked out fingerprints from the ones that we processed and was able to identify them. So first I researched loops. Loops are 60% of all fingerprints are loops. And so what a loop is when you have one ridge enters and exits on the same side, and there's a recurve. So there's left and right slant loops. So right here you can see where it comes in and then comes out on the same side, and that's a left slant loop because it goes in and out on the left. And then over here it's the same thing. It goes in and then out on the right side. And then here I'll show you what I got it from and then what the fingerprints looked like. I'm sorry. Okay, this is just like a CD divider, and careful, this might get on your hands. You can see like the fingerprints on there, and then once we lifted them, you could tell, we did both sides, so I had 4 fingerprints from both sides, and I was able to identify them. So these are 4 from one of them, and there was all 3 of these were loops. On this one you can see that it's a left slant because it comes in, I know it's hard to tell in the picture, but it comes in and out right here, and then the same on this one, it's in and out on the left side, right on the bottom. And then again on this one it's a right slant loop. It comes in and then out right on the right side. And then again on the other side there's also, yeah, that'd be great. It's okay. There's also, this is a left slant loop also, so this is on the other side. You can see where it comes in and out on the left. And then also again, this was from a glass bottle. The finger, you can also see, this one's actually really easy to tell where it comes in and out. You can pass that around too. And then next, I did arches. So arches are 10% of all fingerprints, and it's exactly how it sounds. So it enters on one side, rises, and then exits out the opposite side. It's fairly uncommon for them to flow top to bottom, so it's mainly just left to right. There's 2 different types of arches, a plain arch and a tented arch. So here you can see how it comes in the left side and then goes up and then out the right side, and that's a plain arch. And then a tented arch is almost the same thing, except there's a bigger rise. You can see where it looks like it's almost going straight up here, and that just tells you that it's a tented arch. There's just a higher rise. It's like over a 45-degree angle, I think, is what classifies it as a tented arch. This one, okay, this was a fingerprint that, this is actually one of my fingers. We lifted it, and it's hard to, you can't really classify it as one thing, because depending on who looks at it, if you, like, it looks like an arch at first, but also right here, there could be a ridge that comes in and out on the right side. So it could also be classified as a right slant loop. So depending on who looks at it, it could be classified as two different things. So what they have to do is they have to run it through APHIS, which is the system that's used for identifying fingerprints. They have to run it as both types, because there's a possibility that it could be classified as either by different people. On here, so the top two are loops, like we talked about earlier. It's really hard to tell on these, but it comes in and out on the right side. In E, you really can't tell at all. But on B and C, down in the bottom right, you can see the arch. So like it comes in here and then goes up and comes out the right side. And the same on C, it comes in and goes up and out. Lastly, there's whorls. Whorls are 30% of all fingerprints. You get a whorl when there are two or more deltas. So a delta is, if you look, there's like a little triangle. It's named after the Greek letters, so it's just little, just right here, and then there's one here and here. So if there's two or more with a recurve in front, that makes a whorl. And there's plain whorls, central pocket, double loop whorls, and accidental. So on a plain whorl, it's just circular in the center. There's like recurve in front of both of the deltas, where you can see that it just like goes around. A central pocket is very similar, except for between the two deltas, it continues going straight. So it's almost like a loop goes around the whorl in the center. So that's the difference between those two. And then a double loop is exactly how it sounds. It looks like there's just two loops. So this one, they're kind of right on top of each other. And it can go in any orientation. So this one, there's one here, and then again here. And then an accidental whorl, this is when there's not really it doesn't fit under any of the other categories. Here you can see that it's just kind of crazy. There's kind of looks like a loop here, but it doesn't really fit under any of the other specific categories. Next, so here's the whorl. We had one out of all the ones we lifted, which was surprising because we had more arches, which doesn't normally happen. But here you can see that this is a double loop whorl because there's one, and then there's the other one. They're right on top of each other. For my final product, I learned a lot about the different types of fingerprints and how it was really surprising that we got more arches than whorls because they're so much less popular. That really it really tied together both my original work and my final product. I mean, it was nice that they kind of built on each other. Everything I learned went together. In conclusion, ISM has helped me. It's taught me a lot of things. I've learned time management and public speaking. I've learned how to be professional and use professional language, and it's improved my writing skills. Most of all, definitely public speaking is probably the highlight. I just gave a 30-minute speech, and at the beginning of the year, I could barely do 10 minutes. I think that these skills will help me next year in ISM as well, and also when I go to college, hopefully they'll help me be a better student, and I'll continue to use them. I learned that success doesn't really mean that everything goes the way you planned. If that was true, I don't think success would be very easy, but it just means to work through your obstacles and take whatever comes at you in stride and continue to work through your goal no matter what happens. I'd like to thank my mentor for helping me with everything. It's been great, and I've learned so much. I'd like to thank Coach Goff for